Okay, so arc length. Look at this statement that's above the box. It says the length of an arc is a portion of the circumference. The length of an arc is a portion of the circumference, because we're just talking about some chunk of the whole circumference of the circle. So that is why the formula is what it is. So here's the formula. We use S to represent the arc length. So S equals X. If you look to the right of the box, it says that X is the degree measure of the arc. We're talking about the portion of the circle, so that's over the whole 360 degrees. And then that is times the circumference. Okay, think about it in simple terms. It could be 1/4 of the circumference. Well, of in math means multiply. Just as a reminder, circumference, we've got two different formulas. It depends on what we're given. It's either pi times the diameter, or it is 2 pi times the radius. Okay, if you're given the diameter, use pi times the diameter. If you're given the radius, use 2 pi times the radius. It's the same thing, because 2 times the radius is the diameter, but it's just easier to look at it that way depending on what information we're given. Okay, so let's use this. Find each arc length, round to the nearest hundredth, so 2 digits after the decimal place. Let's look at number 10. If EB is 15, so go to your picture, figure out what EB is. Is it a radius or is it a diameter? It's a radius. So I'm going to make a note of that, so that here in a second, when I plug in my formula, I know which one I'm using. Find the length of arc CD. So let's mark that on the picture as well. CD is the arc right here. When I look at the diagram, I don't have the angle that goes with that arc. What I do have is I have 68 degrees on the angle beside of it. And if I extend the line BD, that is a diameter, right? That's half my circle. So if I do 180 minus 68, that is going to give me the angle that I really need. 180 minus 68 is 112. That is the angle that goes with the arc that I'm wanting to find the length of. So its degree measure is 112 degrees. That's what we've been doing. But we want the actual physical length of it. So the arc length is equal to our angle over 360 times the circumference. Well, we were given the radius, so we're going to use 2 pi times the radius. And then we just crunch the numbers in our calculator. 112 over 360 times 2 times pi times 15. 29.32. It said round to the nearest hundredth. So 32 there. We want to put units on it. This is centimeters. Okay, this is centimeters. It's not squared. We're not finding area. We didn't multiply any units together. We had, these were degrees. The 2 is just a constant. The 15 is the only number with the units on it. So it's 29.32 centimeters. Let's look at number 11. If NR is 8 feet, NR, diameter or radius? Radius. Okay, 8 is a radius. Find the length of arc NMP. So we go from N to M and end at P. So we got to do a little work again. We do have a diameter in here. So we know from N to M to Q is 180. We got to figure out what the distance is from Q to P. So if we know from M to Q is 162, 180 minus 162 is 18. So that gives us that piece right there. We have vertical angles, so that arc from Q to P is also 18. So if we add those all together, 18 plus 162 plus 18, that is the degree measure of NMP. (198). Okay, again, that's the degree measure. We want the actual length. So the arc length is our degrees over 360 times the circumference. We have the radius, so we use 2 pi r. 2 pi times 8. Multiply it all out. 198 over 360 times 2 times pi times 8. Our arc length is 27.65. This one was feet. So the arc length formula itself, pretty simple. Where it may get a little complicated is that you have to sometimes do some manipulation to figure out what your angle is. It's not necessarily just going to be outright given to you. Let's look at number 12. If VS is 12 meters, VS is a diameter. VS goes all the way across the circle, so it's a diameter. Find the length of arc UT. UT. So let's see here. We need that angle. We've got 90 degrees right beside it, and then we've also got 127 on our picture. So I'm looking at this diameter right here. So 180 minus 127 gives us 53. So 53 goes right here. Well, then we also have this diameter. So we already know 90 and 53. So we are left with 37. 180 minus 90 minus 53 should be 37. So our arc length, S equals our angle over the whole, 37 over 360, times this time we had the diameter, so we don't need the 2. It's just pi times 12. So the arc length here is 3.87 meters. Smaller number because when you look at it, it's a smaller portion of the circle. Last one, number 13. If JH is 21, JH, diameter. Find the length of KJG. So we gotta go from K to J all the way back around to G. So we are talking about almost the entire circle, except for that part right there, from K to G. So let's see what we can figure out. When I look at this, I see that I've got half the circle right here. That whole thing's 180. So 180 minus 85 is 95. And that's a vertical angle. So I got 95 over there as well. And all 4 of those angles together correspond to the arc that we're trying to find. So if we add them all up, 95 plus 85 plus 95 plus 59, that's going to give us the degree measure. (334 degrees), almost the entire circle. So arc length is our arc over the entire circle, 360, times, this time it was the diameter, so just pi times the diameter. So our arc length is 61.21 inches. Bigger arc length because we're talking about the majority of the circle there, and it has a diameter of 21 inches, so it has a bigger circumference anyway. Questions about that?